Hi, I am Adil and in this video series we are going to talk about PLC. PLC is the abbreviation of Programmable Logical Controllers. It is a type of industrial computer which is adopted for the control of manufacturing processes. These processes include assembly lines, manufacturing plants, automated devices, or any activity that requires high reliability control, ease of programming, and process fault diagnosis. PLC was first designed to replace hard-wire relays. The reason was that relays have slow response time and their coils require very high currents to energize, which means microelectronic circuits can't drive them directly without additional circuitry. PLC has solved all the problems created by hard-wire relays. Nowadays, PLCs are used for their easy and well understood programming language. Moreover, they have interfacing for inputs and outputs already inside the controller, which means we don't need any extra circuitry to run our systems. PLCs can range from small devices with some inputs and outputs, also known as IOs, to large rack-mounted modular devices with a count of thousands of IOs, and which often network to other PLCs and SCADA systems. They can be designed for multi-purpose digital and analog inputs and outputs. They are also designed to withstand extended temperature ranges, electrical noise, mechanical vibrations, and impact. Program to machine operations are typically stored in battery backed up or non-volatile memory. If we look at the hardware construction of PLC, then PLCs have two types. The first one is called relay type PLC and the second one is called transistor type. Both are used in industrial processes but with different purposes. The relay type PLC have mechanical relays inside it, which means slow response time, and we cannot run high-speed programs in this type of PLCs. On the other hand, there is a PLC with a transistor type. It can perform all types of operations of the relay type with some advantages of transistor type. Transistor type PLC have very little response time and we can run high-speed programs using this PLC. For high-speed program, we can take example of pulse width modulation, also known as PWM. PWM has very high-speed pulses to operate different devices or drives. So if we use relay type PLC, then we can't get an efficient PWM. But by using a transistor type PLC, we can generate PWM signals efficiently. You can think of relay type PLC as a hardwired automatic relay and transistor type PLC as a microcontroller. But there is a question which you might have started to think, that in the past we dumped the hardwire relays from industries and now they again come into relay type PLC. The reason is that there are many old industries which still use hardwire relays. A large investment is required to replace those relay-based systems. To counter this problem, we use relay type PLC in older industries to replace some specific part of the system with PLC. Up to mid-90s, PLCs were programmed using special purpose programming terminals, which often had dedicated function keys representing the various logical elements of PLC programs. Some of the terminals displayed the elements of programs as graphic symbols, but plain ASCII character representation of contacts, coils, and wires were common. Programs were stored on cassette tapes and cartridges. The oldest PLCs use non-volatile magnetic core memory. More recently, PLCs are programmed using application software or personal computers, which now represents the logic in graphic form instead of a character symbol. The computer is connected to PLC through USB, Ethernet, RS-232, RS-485 or RS-422 cable. The programming software allows entry and editing of the ladder style logic. In some software packages, it is also possible to view and edit the program in function block diagrams, sequence flow charts, and structured text. So software provides tools for debugging and troubleshooting of the PLC program. The software can upload or download the PLC program. The functionality of PLC has evolved over the years to include sequential relay control, motion control, process control, distributed control systems, and networking. The capabilities of some new PLC include data handling, storage, processing power, and communication are approximately equivalent to some desktop computers. The most basic function of a programmable controller is to emulate the function of electromechanical relays. A unique address is given to each discrete input, and a PLC instruction can test if the input state is on or off. For this video series, we are going to use Delta's WPL because it is simple and easy to use for beginners. Moreover, this software has simulation, which means we can test our programs without uploading our developed program to PLC. For example, I am going to show you a simple program that I made for on-off bulb switch, and I am going to do it on the simulation software on the WPL soft. So let's take a look. So here we have our program, and it has ladder logic in it. I have made a ladder logic. Now if I run the program, so you can see program is running. So if here Y0 is our bulbs and X0 is our starting switch. Now what this program do is it will remain on for some time and remain off for a specific time. And the started switch is X0 here, which is this one, and the bulb is denoted by Y0. Now if I turn on the X0, then you can see a timer is started, and for 5 seconds the bulb will remain off, and for 3 seconds bulb will remain on. So by using simple logic diagrams and ladder logic diagrams, we can solve our complex problem. I hope you like this video. If you have any questions, please feel free to ask them in the comments below, and stay tuned for the next video. Bye bye.